Hello everyone. From this lesson on, we'll begin discussing component lifecycle methods. To help everyone understand better, in this video, we'll first explain some basic concepts related to lifecycle methods in the engine. First are nodes. Nodes are the basic units that make up a scene. In games, nodes can be characters, props, UI elements, etc. Nodes can be 2D or 3D. And multiple nodes can form more complex node hierarchies, ultimately composing complete scenes. Next are components. Components are functional parts on nodes, containing editable properties that define node behavior. A game object is essentially an empty node with different components added. For example, if developers want a node to move in the scene, they need to add a transform component. If they want a node to emit light, they need to add a light component. Next are scripts. Scripts are special components. During game development, developers often need to implement many complex features that can't be satisfied by built-in system components alone. Scripts are components used to customize functionality. Through scripts, developers can dynamically control node behavior during game runtime, such as moving node positions, enabling or disabling components, etc. Let's demonstrate nodes through examples. Developers can create or manage nodes in the IDE. Nodes added in the IDE are displayed in the scene by default. If you need to create nodes dynamically at runtime, you'll need to do it through scripts. Add a script to the 3D scene with the following content. We first load a prefab resource. Create it as a node and set its position after loading. Then add the node to the scene using the addChild method. The thisOwner method is used to get the script owner node object. This method is very commonly used and developers should be familiar with it. After running, we can see a cube has been added to the scene. Developers can set whether nodes are activated in the IDE. For 3D nodes, if a node is inactive, it won't be added to the render queue, and scripts on the node won't execute. Here, we deactivate the cube added to the scene. After running, the console shows no output and the cube doesn't appear in the scene. For 2D nodes, node inactivation only affects script execution on it, not the node's rendering display. Add an image to the scene with a script that makes it rotate continuously. When the node is active, running shows the image rotating normally. When the node is deactivated, running shows the image still displays normally but doesn't rotate. Note that when a node is inactive, script execution on the node stops at the onAwake method, but the onAdded method executes before onAwake. So even if the node is inactive, onAdded will still execute when the script is added to the node. Developers can also dynamically change a node's activation state during runtime by changing its active property value. Next, let's demonstrate components. Developers can add or remove components for nodes in the IDE, or dynamically add or remove components through scripts. Let's add a script to the 3D scene to add a script component to the cube node in the scene. The first step in adding components and scripts is getting the node. For nodes added in the IDE, developers can expose properties through decorators to pass nodes directly. For dynamically added script nodes, you need to get nodes through methods like getChild. First get the script's owner node through this.owner. Then get child nodes through getChildBenom. After successfully getting the node, you can add components to it using the addComponent method. Run to check the effect. Clicking the Add Component button shows the script component successfully added. Finally, let's briefly introduce component script lifecycle methods. Lifecycle methods are essentially a series of functions that automatically execute in sequence when scripts run. By implementing these methods, developers can conveniently design game logic. Layer Engine has the following lifecycle methods. onAdded executes after the script is added to the component. onAwake executes when the script is first activated, and only once. onAble executes each time the script is enabled. onStart executes before an update and only once. onUpdate executes every frame update. onLetUpdate also executes every frame update but after an update. onPreRender and onPostRender execute before and after rendering respectively. onDisable executes when the script is disabled. onDestroy executes when the node is manually destroyed. onReset executes when the node is destroyed, automatically resetting the script and recycling it to the object pool. That's all for this lesson. Thank you for watching.